Okay, so we're going to be doing the Systems of Equations chapter in my new version of the SAT math book, the one that's updated for the digital SAT math exam. So let's start with number 1. John's bookshop sells 2 types of books, hardcover and paperback. Hardcover books sell for $15 each, and paperback books sell for $5 each. Last week, he sold a total of 30 books and made $250. How many hardcover books did he sell? So we want to know hardcover books, how many hardcover books he sold. Now it says that the hardcover books are going to be $15 each. So I'm going to just call like the number of hardcover books H. So I'm going to say that 15 times H plus it's $5 for each of the paperback books. So I'm going to say 5 times the number of paperback books that they sell, P. If I add those values up, I'm going to get the total that they made, which is $250. So there I have one equation. Now I can have a second equation by looking at this part right here that says he sold a total of 30 books. So the books are going to be the hardcover books plus the paperback books. And that's going to equal 30 books. Now I have a system of equations, that I've set up, and now I can solve it to figure out what H is. Now, in order to find out what H is, I'm going to do substitution. That just seems easiest to me. So I'm going to get P by itself by subtracting H from each side. So then I know that P must equal 30 minus H. So this is called substitution because now I can substitute this in right over here for P. So now instead of writing P, I've written 30 minus H right there because I know it's the same thing. And then now I just have to distribute this 5 to each of the terms in parentheses. And then I'm going to combine my like terms of the 15H and minus 5H. So 15H minus 5H is just going to be 10H. So now I have 10H plus 150 is equal to 250. Now I just need to solve for H. So I'm going to subtract 150 from each side. When I do that, I'm going to get 10H is equal to 100. And then I'm going to divide by 10 on each side. When I divide by 10 on each side, I get that H, the number of hardcover books, is going to be 10. So the answer would be A. So now let's go to number 2. So you can pause and read this if you'd like. And basically the equation that we would first have is the price for each of the tickets. I'm going to call the number of adult tickets A and the number of child tickets C. So it says that the adult tickets sell for $15 each. So 15 times the number of adult tickets would tell me how much I spend on the adult tickets, plus $7 times the number of child's tickets, 7C, would tell me how much I'm spending on the child's ticket. So if I add those up, I get the total amount that was paid, which is $150. Now I can get a second equation from this information right here, which says they purchased a total of 18 tickets. So all the adult tickets, A, plus all the child's tickets, C, is going to equal 18. Now I have my system of equations, and I want to know how many child tickets they buy. So I'm looking for C. So I'm going to get A by itself by subtracting C from each side, and that's going to give me A is equal to 18 minus C. Now, just like the other problem, I know A is the same thing as 18 minus C, so I can just substitute that in for A. And then now I just need to distribute the 15 to the 18 and to the minus C in there. And then I just need to combine my like terms here of minus 15C and plus 7C. So when I do that, I'm going to get negative 8C. So 270 minus 8C is equal to 150. Now remember, I'm solving for C, so I'm trying to get that by itself. So I'm going to subtract 270 from each side. And when I do that, I get negative 8C is equal to negative 120. So to get C completely by itself, I just have to divide by negative 8 on each side. And when I divide by negative 8 on each side, I get C is equal to 15. So the answer would be C. So now let's go to number 3. Again, you can pause to read if you'd like to do that first. So I'm going to do, again, a lot of these follow the same format of like the price per each thing times it plus like the other thing, like for instance, in this one, it's pens and notebooks. So I'll say the number of notebooks is N, the number of pens is P. So like the price for each pen times the number of pens, like the price of the thing times the number of things for each of them, and then add it up equals the total. It's kind of like formulaic, or is that even a word? I think it is. But anyways, so it would be 125 times the number of pens you sell, And then for the notebooks, it would be 2.5. It could technically be 2.50, same thing, times the number of notebooks you sell, N, is going to equal the total cost, $10. So then if the total number of items is going to be 5, that means that the number of pens plus the number of notebooks equals 5. So now you have a system of equations, and you're trying to solve for what N is, the number of notebooks. So I'm going to get P by itself to do that. So then P is equal to 5 minus N. So I know P is the same thing as saying 5 minus N, so I can just put that in here instead of P. That way I can just have N to solve for. So that's what I'm going to do now. And now I just have to do distributive property, which just means I'm multiplying whatever's outside here, 1.25 times the 5, and then also times the negative N. And then I get this, and now I just have to combine these like terms right here because they both have an N with them. And then I'm trying to solve for N, so I want to get N by itself by subtracting that 6.25 from each side. So then I get this, and now to get N completely by itself, I have to divide by 1.25 on each side. So then N would be 3 when I do that, so the answer is C. Again, pause to read if you'd like to do that first, but here's the explanation for number 4. So again, it follows that same sort of formula where like I'm going to call the number of tokens T and the number of quarters Q. So I would do 0.5 times the number of T tokens plus 0.25 times the number of quarters is going to give me the amount of money, the total amount of money collected, which is 125. And then for my other equation, it's just going to be the total, like when I add up all the tokens and quarters. So when I do T plus Q, it says it equals 350. And I'm trying to find out how many tokens. So I'm solving for T right now. So I want to get Q by itself so that I can substitute in. So I'm going to subtract T from each side. I'm going to get 350 minus T is equal to Q. So Q is the same thing as 350 minus T. So I'm going to just substitute that in. Then I'm going to do distributive property right here. Now I'm going to combine like terms. Now I'm going to subtract the 87.5 from each side because I'm trying to solve for T. Now to get T completely by itself, I'm going to divide by 0.25, and when I do that, I get T is equal to 150, so the answer would be C right there. So for number 5, I'm trying to find out how many real solutions there are, and remember, whenever you see the words like real solutions with something that's a quadratic, meaning like the highest exponent that you see is a 2, you're probably going to have to use what's it called? The discriminant formula, I think is the name of it. I'm terrible with like names of things, but it's the one that looks like this. So b squared minus 4ac, and like if it's less than 0, greater than 0, or equal to 0, that tells you how many real solutions you have basically. So we're gonna solve for what this is, and then based off of if it's positive, negative, or equal to 0, we know how many real solutions there are. Now what A, B, and C are correspond to the same exact thing that you're used to with the quadratic formula. So like the A is going to be the coefficient in front of the x squared term, the B is going to be the coefficient in front of the x, and then the C is going to be like the number floating by itself. So since this is a system and we're looking for the solution in a way, we have that they're each set up equal to y, right? So let's just set them equal to each other, because remember the solution to a system is going to be the x comma y point that they intersect at, like basically a point that works for both of the equations. So like if the y works for this equation and it's part of the solution to the systems, then it should be the same y over here in the other equation as well. Because the whole point is that it's a point that works for both, an x comma y that works for both. So let's do that. We're going to set them equal to each other. So I'm going to say x squared minus 4x plus 4 is equal to negative 4x squared minus 4. So now, this is also important, I want to make sure that I have a quadratic set equal to 0 before I determine what A, B, and C are. So in order to do that, I'm going to add 4x squared to each side. That way, I can get rid of it on this side and get closer to making this side 0. So then I'm going to have 5x squared minus 4x plus 4. Oopsies. Get rid of that. Is equal to negative 4. Now, all I have to do to get this side equal to 0 is just add 4 to each side, because then it's going to cancel it out there and move it over here. So I'm going to have 5x squared minus 4x, and when I add 4 over here, I get plus 8, and that's now all equal to 0. Now let's determine what a, b, and c are. Now remember I said a is just like with the quadratic formula, it's gonna be the number that's being multiplied by x squared. So like whatever's in front of x squared basically, like the number being multiplied by it, is your a. So 5 is equal to a. Whatever is being multiplied by the x term is going to be your b. So -4 is the whole thing to the left that's being multiplied by x. So don't forget that negative, it counts, it's part of that. So b would be -4, and then c is just the number floating on by itself. So c would be 8. So now I just need to plug each of those in to this right here. So b is -4, so I have -4 squared minus 4 times a, which is 5, times c, which is 8. So I've plugged it in there. Now I'm going to solve it to find out if I have something that's positive, negative, or equal to 0 to tell me how many real solutions there are. So -4 squared is going to be 16, and then that's going to be minus 4 times 5 is going to be 20, and then times 8 is going to be 160, so minus 160. So this, you don't even actually have to solve all the way through. Like I just know this is going to be a negative number. You can if you want to. So I'm going to get a negative answer, something that is less than 0. So this whole thing ended up being less than 0. When that happens, that means you have no real solutions. So it would be D. Okay, so now let's try number 6. So it's asking what is the solution, x, y, basically what's the x and y that works for both of these. So there's a couple things you can do. I've been showing you substitution so far, so with this one I'm going to show you how to do something called elimination. So with elimination, you usually want to use that one when like you can easily see how if you add or subtract these equations some way that you're going to be able to cancel out one of the terms easily. So like usually when you see something like copied or like the same for both of the equations, that's when like it's kind of a giveaway where elimination might be easier, like with the -2y and -2y, or like if there was a negative and a positive, like -2y, positive 2y, that would be another giveaway. But you can totally do substitution if you want to. So what I'm going to do here is I see that if I were to subtract these equations, because like if I subtract this whole bottom part right here, minus a minus is a plus, so then that would be plus 2y. And then I would have -2y plus 2y, which would cancel out, and then I just have x to solve for. So that's what I'm going to do. Remember, whatever you're doing, you have to do the entire equation. I can't just subtract the -2y. I'm subtracting the whole thing on the bottom. So I'm doing this top equation minus this bottom equation. So -7x minus x, because that minus has to go to that x too, is going to be -8x. So then I'm going to have -8x. And then now I'm going to do -2y minus -2y, which is -2y plus 2y, which just cancels out to 0. Then I have an equal sign, and then now I have -13 minus 11. -13 minus 11 is going to be -24. So now I just need to divide by -8 on each side, and that's going to give me that x is equal to +3. So automatically I can cross out c and d because I know that a and b are the only options with a 3 as my x value. Now to figure out what y should be to determine which of these is the correct answer, I can pick either of these equations. I'll do the bottom one. X minus 2y is equal to 11. You pick either of the equations, and whatever you got for that variable that you just solved for, which in this case is x, just plug that in and then solve for y. So I'm going to plug in 3 for x because I know x is equal to 3. And then I'm going to solve for y. So I have -2y is equal to, I'm going to subtract 3 on each side, and that's going to give me 8. And then I'm going to divide by -2, and that's going to give me -4. So the answer would be A. Okay, so now let's go to number 7. So again, pause to read if you want. And then it's asking, what is the price per gallon of diesel? So we want to know the price per gallon of diesel. I recommend always underlining what you're being asked to find so that you don't accidentally answer the question wrong. And you'll see how that happens with a lot of students with this question. So I'm looking for what I underline, the price per gallon of diesel when it's equal to the price per gallon of regular gas. So remember, D and R are those prices. So we want to know the price D of diesel when these equations are equal. So first I need to figure out what is the x value that these are equal at, then I can plug in that x and solve for d. Now, if you don't underline what the price per gallon of diesel is, you might accidentally find x and be like, I'm done. But that's not what they asked you to find. They asked you to find d. So you gotta be careful with that. So I'm gonna set these equal to each other. So I'm gonna say 3.5 plus 0.25 x is equal to 3 plus 0.35x. And then I'm going to now try to get the x's together on one side. So I'm going to subtract 0.25x from each side so I can move it over here. And that's going to leave me with this. Oh, I forgot the 0 right there almost. It doesn't matter, but I just like to make it clearer for people when they're watching this. So then now I'm going to subtract 3 because I'm trying to get x by itself. So I need to move stuff away from x now. So subtract 3 on each side. That's going to give me 0.5 is equal to 0.10x. So now to get x completely by itself, I need to divide by 0.10 on each side. So then that's going to give me that x is equal to 5. Now remember, we're trying to find d. We found x, so now we can plug this 5 in for x right here. So then it becomes 0.25 times 5 plus 3.5. So we would plug that in there, and when we solve that, what we're gonna get for our answer is going to be 4.75, right there, C. Okay, so now let's go to number 8. Given the systems of equations above, what is the value of x? So underlining what I'm finding, the value of x. So again, I see like these are pretty similar, but with elimination, like you don't wanna always just go with like canceling out what's similar, because if you cancel out what's similar here, like let's say I subtracted all of these, x minus x, then you don't have an x to solve for anymore. So it's kind of redundant to do that. So I just wanted to like point that out with this problem. Like that's not always gonna be like a straightforward method where you just automatically eliminate whatever's the same. I mean, you could and then plug it in and solve for what x is, but that's kind of like a roundabout way of doing it. So another way that you can do elimination is that you can just alter one of the equations in some way by multiplying by some number, the whole equation by some number, so that it eliminates the other variable that you need eliminated easily. I know that's kind of like a tongue twister, but you'll see what I mean in a second. So I see that if I multiply this entire equation right here by 2, and I just cross out the 8 because I don't want people to get confused and think that's part of the equation. So this equation right here, if I multiply it by 2, I'm going to get 2x plus 2y is equal to 10. Now, on the bottom, I'm going to keep my whole equation right there the same. And I'm going to add these equations together, because if I do that, I see that these nicely eliminate or cancel out. So then 2x plus x is 3x. 10 plus negative 11 is going to be negative 1. So then now if I divide each side by 3 to get x completely by itself, I get x is equal to negative 1/3, the value of x. So it would be D. So for number 9, we're going to find the value of y. Oops, that was a bad underline. The value of y for this. So we're solving for y basically. So let's take a second to look at what might be the best option here. And also just FYI, because like the best option here for, since it's the digital SAT and you have access to Desmos or like an approved calculator that you bring, would be to graph to solve. So I'll show you how to do that in a second. But the reason I'm showing you the substitution elimination way is because for some people that is faster, and or they don't know how to use Desmos, stuff like that. So I'm trying to show you like a variety of ways to do these problems, but pick whatever's best for you. You could use one method, like substitution, elimination, graphing, for solving any system that you want. It's not like certain ones you can only graph with or stuff like that. It might be like easier for some people to do one method versus the other. So let's go and try to graph this now. So now on Desmos, this is built into, I forget what it's called. I think it's like Blue Book or something like that. Like it's built into the digital SAT exam. So you'll have access to be able to use Desmos just like this. So all you have to do to like graph it is just type in what the equation is. So like the first equation for number 9 said that it was y is equal to negative 5 thirds is what it says. So minus 5 divided by 3 And then it's going to be minus 5/3 times x. So I'm going to put an x there, right there. And then I'm going to say minus 7. Oops. And then the second equation, you just go to like the next line and you do the same exact thing. Just type in exactly what the second equation says. So y is equal to negative 16 divided by 9, and then times x right there, and then minus 8. So now I have both of these lines graphed. And remember, the solution to a system of another way to think of the solution to a system of equations is the point of intersection. Where do they intersect? Well, let's zoom out a little bit and let's see, where are they intersecting? Where do they cross? So, I mean, you could have seen it right there, but I'm kind of like trying to zoom in so you can see it even better. So they're meeting, or they're crossing at that negative 9, 8 point right there. And remember, the question asked what's the y value that's the solution. What is the value of y for the solution to the system of equations? So the y is going to be this number right here, 8. So 8 is going to be our answer for number 9. Now you could do the same exact thing again with all of these if you wanted to. But I'm gonna try to show more of like the harder way to do it, because I know some teachers and stuff, like you might be using this for class, like algebra 1 stuff maybe, or algebra 2 if you're reviewing, and like your teacher might say like, do this problem using substitution, or do this problem using elimination, which are like the harder ways to do it than just typing into a graphing calculator. So I'm gonna try to show how to do it those ways. So for this one, again, I'm going to cross out this 10 because it's just number 10. That's not part of the equation. So I'm trying to find the y coordinate, and let me actually zoom in a little bit here. I'm going to try to find the y coordinate of the point of the intersection point, which is just another way of saying solution. There's just like a million ways to say things in math, but it's just saying like the intersection point, the y coordinate is just like another way of saying the solution, the y value that works for both. So when you have decimals, if you're solving this out like without a graphing calculator, one easy trick that you can do is you can say, okay, I'm going to multiply each of my equations by a certain value that makes the decimals go away. So for instance, I see that like in order to get these to be whole numbers for all the decimals, they each need to move the decimal by 2. So if I multiply by 100, because 100 has 2 zeros, so it'll move the decimal place 2 to the right for each of these, I can get rid of the decimals. And that's totally fine to do as long as you do it to the entire equation. So that's what I'm going to do here. Again, you could do the decimal way if you want to, but it's just going to be a lot more annoying to divide and everything. So then this is going to be x plus 4y is equal to negative 28. And then this is just going to be 9x plus 8y is equal to 0. So now let's just do substitution, or actually I could just do times negative 9, I mean, to get rid of the what do you call it, the x value, so then I can just solve for y. So now I'm multiplying by negative 9 because I'm trying to get rid and cancel the x's, not the y's. So then negative 9 has to be multiplied by each of those, so then this becomes negative 9x minus 36y is equal to, now we're going to do negative 9 times negative 28, and we get 252. Then I'm going to just copy down the other equation, and then I'm going to add these together. So these cancel out, so then now I just have negative 36y plus 8, and that's going to be negative 28y is equal to 252, because 252 plus 0 is just 252. And then I have to divide by negative 28 on each side. So then when I do that, I get y is equal to negative 9. So the answer should be C, negative 9. Sorry about that little mix up. So basically, if you're confused, like just skip to where I started all over and just ignore everything I did at the beginning of this problem until I started here multiplying by 100 and got to these guys over here. Maybe I'll upload like a video later of me just like completely redoing the problem. I don't know. I just know that whenever I edit, it goes very badly. So I don't want to accidentally cut out something from the video. So let's go to number 11 right here, and we're trying to find out what is the value of 5x plus 7y. So one thing that you can do here is you could do the regular solving way, like find out what x, find out what y is with whatever method you want, and then plug those in to this right here, like plug in what you get for x, plug in what you get for y, and solve this. Or right away from looking at this, I see if I add these up, I'm actually going to get 5x plus 7y. So 2x plus 3x is going to be 5x. 4y plus 3y is going to be 7y. Then if I add these up, I get 2,900. And you see now I have 5x plus 7y equals this. So that's my answer. So for number 12, again, I'm going to cross this out so you don't get it confused and think it's part of the problem. We have this system, and we're trying to find out the values of b that it has no solution. So whenever they're asking you to like find out like something that's with systems of equations that there's no solutions or infinitely many solutions, in some capacity, you're going to have to manipulate the equation so that they look as similar as possible. Because when you have the same exact equation for both, that's when there's infinitely many solutions because it's the same line. And then when you have like basically an impossible situation where they're mostly the same, but they equal like one number is different in each of them, like that, then you have an impossible scenario where like, for instance, if you had like 2x plus y is equal to 1, and then you had 2x plus y is equal to 2, like that's not possible. Like you can't, like you see how like one number is different. You can't do 2x plus y, get 1, and then also get 2. So that would be like an impossible situation where there would be no solution. But you would have to get the equation to look sort of similar. So like each way, whether it's infinitely many solutions or like no solutions, you're still trying to get the equations to look as similar as possible to some capacity. So let's go now back to this problem. That was just an example to show you those equations I wrote had nothing to do with this problem. It was just a separate example. So now what we're going to do is look at this problem, and we're going to see, okay, how can we manipulate this so that they look fairly similar? So I'm going to say, okay, I'm going to multiply this top one by 2. That way I can get it to look like 2y. So then I'm going to multiply that by 2. So then it's going to be negative 12x plus 2y is equal to 14. And then I'm going to just write the bottom equation right here so that you can see it simultaneously. So they're asking like what value of b would make this situation impossible so that there's no solution. Well, that would mean that to get this to look as similar as possible, where it would be equal to like two completely different numbers, which would make there be no solution, I would have to make b be negative 12. So that would have to mean that the answer is A. Another way that you can think about this is that parallel lines never intersect, and like the solution to a system has to be like a point that they intersect, a point that works for both. If they never intersect, there's never a point of intersection that works for both. There's never an x and y that works for both. So you can also think about it as if you can see that they're parallel lines, that they would have the same slope. So there's kind of like different ways about going about it, and that they would never intersect if they're parallel lines. So that's another way of thinking about it if you want to do it that way. And also, since you have on the SAT, on the digital SAT, since you have access to Desmos now and like your graphing calculator, you could also have just like checked this by like plugging in each of these values for like B right here into Desmos, and then seeing like if you got parallel lines for no solution, or like you didn't even have to like know that they're parallel or whatever. You just have to see that there's like nowhere that they're crossing. There's no point that works for both. Like you would see that if you plug in negative 12 here and graphed both of these equations, that they never touch, they never intersect. But if you were to plug in each of these other points for B, like if you did the equation negative 6x plus 2y is equal to 12, and then you plugged in the top equation as well, you would see that those do cross. So, okay, for number 13, we're trying to find the value of n. And we have these two equations right here. Now remember, whenever they give you a point of intersection, they're giving you the x comma y. That's the solution to the system. So they're giving you an x comma y that works for the given system of equations. So that 3 would be your x that works, and that 9 would be your y value that works. So we could say, okay, the y's are going to be equal when we are at the solution or the point of intersection for the system of equations. So I'm going to set the equations equal to each other. Negative mx is equal to nx plus m is what that says, yeah. And then I could say, oops, I could say, okay, I'm going to plug in, what is it, 3, sorry, my eyesight is not great. Yeah, that's a 3. 3 for x, and then there's no y right now, but we're gonna plug in 3 for x, so then it's gonna be negative 3m is equal to 3n, because x is 3, 3 times n is 3n, plus m. Now you'll see the issue is we don't know what m is, so we have two unknowns here. But what we could do is we could just pick one of these equations to find out what m is. So I'm going to pick this top equation right here that only has m, x, and y because I know what x and y are. And then I can plug them in. So my y is going to be 9 and my x is going to be 3. So then I have 9 is equal to negative 3m. If I divide each side by negative 3, I get that m is equal to negative 3. So now I can plug that in for m right here and solve for n. So then I have negative 3 times negative 3 is going to be positive 9 equals 3n plus negative 3. Now I'm going to, you could technically just say like plus a negative number is just subtracting. So I'm going to just go ahead and do that. And then I'm going to say, okay, I need to get n by itself, so I need to add 3 to each side. When I do that, I get 12 is equal to 3n. And when I divide by 3 on each side, I get n is equal to 4. So the correct answer would be D. So now we have, we want to know what's the value of A over B, so I'm going to underline that. And we want to say that the system has infinitely many solutions. And also people get confused about like what constants means. A and B are constants. That just means that like, think of it as like they're numbers. Like that's what basically that means. It's just a fancy term. So if the system has infinitely many solutions, what is the value of A over B? So infinitely many solutions, remember with no solutions or infinitely many, we're trying to get it to look as similar as possible. With infinitely many, we want to have the exact same equation, because if there's infinitely many solutions or infinitely many points that work for both, infinitely many points of intersection, that means like they're right on top of each other. Like every single x and y is the same. They're the same line. So we're going to try to do that and get these to look as similar as possible. So I'm going to see, okay, well, 21 and 7. Okay, I know that if I multiply this by 3, I'm going to get this to be equal to 21 because 3 times 7 is 21. So I'm going to start there. So I'm going to just copy over the top version right there. And people think that my A's look like 2's. I'm sorry, but that's an A, just so you know. My 2's look like this. And then we are going to go over here. And, sorry, I have a little OCD. And then we're going to multiply each of these terms inside the parentheses by 3. So then this is going to be 12x. And then it's going to be minus 3by is equal to 21. So you see how they're looking similar now? Now remember, if we want infinitely many solutions, this has to be the exact same equation. So that means that whatever's in front of x has to be the same and whatever's in front of y has to be the same. So automatically we know, okay, A has to equal 12 to get those to be the same. And then we know that negative 3b has to equal negative 5. So we know A is 12. Now let's just divide by negative 3 on each side to get b by itself. When I do that, I get 5/3 for b. So now to do A over b, it would be 12 over 5/3. And remember, a fraction bar is the same thing as a division sign. So this is the same thing as saying 12 divided by b, or A divided by b, which would be 12 for A, divided by b, which is 5/3. Remember, when you are doing division with fractions, you need to keep, change, flip, KCF. Each of those lines up with what you're doing for the steps. So like the K in keep lines up with keep this number, 12, and technically that's 12 over 1. Same thing, change the division sign to multiplication, and then flip the 5/3 to be 3 over 5. So like you just flip it over where the bottom goes to the top, top goes to the bottom. And then you just multiply across. So then 12 times 3 is going to be 36. 1 times 5 is going to be 5. So it's just 36/5. Or that's also 7.2. Either one is fine. So for this one, we're trying to find a possible value of y. Possible value of y for the system. So let's see, what would be the easiest thing to do? Would probably be substitution, since y is already by itself right here. So y is the same thing as saying, because it's equal to root x plus 2. So instead of saying y for the second equation, I'm going to put root x plus 2 because they're supposedly equal. So that's what I'm going to do in the second equation. I'm going to rewrite it so that it's root 16x minus what y is, which is just minus the whole thing for y would be root x plus 2. So remember, you're not just minusing the root x part, you're minusing the whole thing that's supposedly y, that's equal to y. So you have to subtract the whole thing, the whole root x plus 2. That's why I put it in parentheses, so I know to apply that subtraction symbol to each of those terms inside the parentheses. And that's going to equal 2. So all I did was I just substituted in root x plus 2 for y in the second equation, and now I'm going to distribute that minus sign to each of the terms in parentheses. So that's going to be root 16x minus root x minus 2 is equal to 2. Now, root 16x, 16 is one of our perfect squares, where 4 squared is equal to 16, so I can take out a 4. So then I have 4 root x minus 2 is equal to 2. So now I can combine my like terms here. So 4 root x minus root x is just going to be 3 root x. And then I copy down the rest. So now I'm going to add 2 to each side. And when I do that, I'm going to get 3 root x is equal to 4. So now I'm going to divide by 3 on each side. So then I get root x is equal to 4/3. And then I want to solve for, well, actually, I don't even need to solve for what x is, because what I could do to just make my life easier is I could say, oh, I'm going to just take this first equation. I'm trying to find out what y is. So y is equal to whatever root x is plus 2. So I already know root x is 4/3. So that means y has to equal to 4/3 plus 2. Now 2 is the same thing as 2 over 1. To make these, to be able to add these fractions, you have to have a common denominator. So I'm going to multiply by 3 on top and bottom, so I can get 3 on the bottom as well there. And then that's going to give me y is equal to 4/3 plus 6/3. And then when I add those numbers on top, I get 4 plus 6 is 10. Keep the like denominator, so I get 10/3. The correct answer would be D. So number 16 wants to know like how many solutions are there. So right away, I'm gonna try to see if I can make them look as similar as possible, because that would be the way to find out if there's 0, like no solutions, or more than 2, like infinitely many. So right away, I see if I multiply by the bottom by -2, I can make that -5 turn into a 10. So let's see how that affects the rest of the equation. So -2 times -x is going to be positive 2x. -2 times positive 2y is going to be -4y. -2 times -5 is going to be positive 10. So, and I have that same exact equation on top right over here. So same exact equation, same exact line right on top of each other. They have infinitely many solutions. So the correct answer would be D. Okay, so for number 17, we want to know how many regular pizzas, were sold that day. So let's call the number of pizzas P and the number of drinks D. So sells regular pizzas for $15 each. So 15 times the number of pizzas P would be how much for the pizzas. And then the drinks would be $3 for each drink times the number of drinks. And that's going to equal the total, which is going to be $1,062, the total amount of money that they get from selling those pizza and drinks. Now, if I know there's a total of 250 pizzas and drinks, meaning the number of pizzas P plus the number of drinks equals 250, I have this equation right here. Now remember, I'm trying to solve for, that's a terrible 0. I'm trying to solve for, it keeps happening. 1 second. There we go. Okay, I'm trying to solve for P basically. I want to find P, the number of regular pizza. So I'm going to try to get D by itself in the second equation by subtracting P from each side. So then I get D is equal to 250 minus P. So I know D is the same thing as saying 250 minus P. So I could plug that in for D right here and then solve for P. So that's what I'm going to do. Now I'm going to distribute this 3 to each of the terms in parentheses. So I distributed the 3 to each of the terms right here with the arrow. And then I just combined my like terms of 15P and minus 3P to get 12P. Now I'm going to solve for P by subtracting 750 from each side. And when I do that, I get 12P is equal to 312. And then if I divide by 12 on each side, I'm going to get that P is equal to 26. So that would be the answer, B. Right here, 26. Oops. We have to find out what is the value of K. So we have these equations that they tell us are the same line. So another way to think about this, that's just saying that like we have a systems of equations with infinitely many solutions, because that means that they're the same line. So I'm going to stack these on top of each other so that we can look at them simultaneously so it's easier. So remember, I have to try to make them look exactly the same for them to be the same line. So I see that if I multiply the top by 2, I can get the x part and the y part to look the same if I do the top by 2. So then that's going to be 2x plus 6y is equal to 30. I just multiplied 2 by each of those terms. And then I'm going to just copy over that second part right here to be 2x plus 6y is equal to k. Now remember, they have to be the exact same equation, same line they said, so that means that 30 has to be equal to k, so that would be my answer, 30. Okay, so you can pause to read this whole excerpt if you want, but remember I told you a lot of the stuff that you're going to see is like very like formula based kind of in a way with like systems of equations with the word problems. And this is another example of that. So basically they're asking you to find the system of equations that matches the situation. So they said that B is going to be the number of tickets for balcony seats and F is the number of tickets for floor seats. Well, the balcony seats cost $80 each. So that means 80 times the balcony, number of balcony seats B, tells us how much they spent on the balcony seats. And if we add on what they're spending on the floor seats, which would be 50 times the number of floor seats, F, if we add those up, we should get the total amount, which would be $30,000. So right away, let's see what matches that. Would have to be, I think the only one that matches that is D. Yeah. And then you, just for like the other part, B is the total number of balcony tickets, F is the total number of floor tickets. So if we add up number of balcony tickets plus number of floor tickets, we get the 500 total tickets sold. So that's the explanation for the second part of that. Answer choice D, which is correct. Okay, so for number 20, it's asking how many solutions are there for the system of equations above. So let's see, right away I'm going to try to get y by itself over here so I can just set these equations equal to each other. So I'm going to subtract 7 from each side and then add 3x so that it can move to the other side and get y by itself completely. So it's going to be y is equal to 3x minus 7 now. And then we have still that same top equation. So I'm going to set my y's. Well, there's no way to, like, the reason I'm not trying to make them look exactly the same is because I can already tell, like, there's no, like, number I can multiply this by to get, like, x squared minus 2x minus 5 or anything close to that. So automatically I just see, okay, I'm probably gonna have to set these equal. So I'm gonna set the y's equal, are equal to each other if we're at the solution. So that means it has to be x squared minus 2x minus 5 is equal to 3x minus 7 right there. So then you could like technically just solve also is a way to go about this, like just solve and see like how many solutions there are or if there's no solution. So I'm gonna go about that way of doing this rather than like the other ways I've shown you with like discriminant formula and stuff like that. So I'm gonna actually I'll add 2x to each side. I'm gonna add 2x to each side. And that's gonna give me this, x squared minus 5, because it cancels out if I add 2x to each side, is equal to, add the 2x there, I get 5x minus 7. Now I'm gonna add 5 to each side. and then I'm going to have well, equals 5x, add 5 to each side. Sorry, it's a little late right now. And that's going to be -2. I should have actually just done it the other way. So I'm going to just now move everything over here so I have it set equal to 0. I was thinking that like the x's were going to cancel out for some reason. So that's why I was like, oh, I'll add 2x to each side. I don't know why I thought that. But now I can't, like, there's no x squared equals 4 or something easy like that. So I have to actually just set the quadratic equal to 0. So I'm going to actually just go back and subtract 5x. Add 2 so that I have it all equal to 0. What I could have done originally is I could have just started like up here by subtracting the 3x instead. It probably would have been easier. So like if I go back to my original part right here, what I would have done now retroactively, like thinking back, I would have said, okay, I'm going to subtract 3x to make my life easier instead. And I'm going to get -5x. -5 is equal to -7. Then I'm going to subtract, or sorry, not subtract, add the 7 to each side. That way I can get it equal to 0 over there, my quadratic equal to 0. So if I add 7 to each side, I would have gotten this. Like either way works. I just like didn't see it until now to do that, but you could have also done that the other way. So then now I have a quadratic equal to 0. So now I'm going to see, okay, can I easily factor this? And you could have solved for the solutions that way. Now this one actually isn't easily factorable, so like you're not gonna be able to find the exact solutions without doing like quadratic formula and stuff. So I'm gonna just go ahead and actually just do discriminant formula, but this is how you would like set it up to actually solve it if you wanted to. In the quadratics chapter, like doing quadratic formula, like you can go look at that later when I post that, if you wanna see like how to solve these sort of things. But again, we're not looking for the exact solution, just the number of solutions, and it's easier to just use discriminant formula right now. So remember, discriminant formula is that thing that I said, b squared minus 4ac. We figure out like what a, b, and c are, plug it in, and then if it's positive, it's going to have 2 solutions. If it's negative, it's going to have 0 solutions. If it's equal to 0, it's going to have 1 solution. So a is going to be the number in front of your x squared, which technically there's a 1 there, so a is 1. B is going to be -5, and then c is going to be your 2 right there. So I have -5 squared minus 4 times a is 1 and c is 2. So -5 squared is going to be 25, and then this is going to be -8. So I get a positive value, so then I know there's exactly 2 solutions. Now let's kind of go back to like using Desmos to see like, to show you how for like number 21, you could also use it like this way. So if you want to know how many solutions there are, like, or how many, another way of saying that is how many points of intersection there are, you could just input each of these into Desmos and then see like at how many places do they cross. And that tells you then either the number of points of intersection, or another way of saying that is the number of solutions. So you'll see all I did was type in each of the equations, and you'll see they only cross at this one point. So there's 1 point of intersection or 1 solution. So the answer would be B. So now let's go to number 22 here. This is one that a lot of people have struggled with, these types of problems. For the system of equations shown above, k is a constant given that the system of equation has no solution. What is the value of k? So we want the value of k, and there's going to be no solution to the system. So let's see. So I'm going to first try to get these to look as similar as possible. Again, because remember, when we're looking for a system of equations with infinitely many solutions or no solutions, that's like kind of like the first step we do. So I see like up here, I just have like whatever times y by itself equaling something. So I'm going to try to get this to kind of look like that by moving away this 72x to the other side. So I'm going to add 72x. So I'm working with this equation right now. And I'm going to say that's minus 90y. If I add 72x to each side, it cancels out there. And then I have negative 36 plus 78y plus 72x. Now I want to get the y's together on one side, just like they are over here. So I'm going to subtract 78y from each side. It's going to cancel it out there. And then I'm going to get negative 168, y is equal to negative 36 plus 72x over here. So you see how now it looks a lot more like that top equation and how it's set up, where it's just like a number plus something times x is equal to something k times y, or in this case, it's negative 168. So now I'm going to think, okay, how can I make these look even more similar? So I'm looking, remember, I'm focusing on this equation right here and this top equation right here. So I can get this to look even more similar with the x part. So how can I get 72x to be 12x? Well, I could divide by 6. So I'm going to divide this. Remember, when you divide or multiply the equation, you have to do it to the whole thing. So I'm going to divide the whole thing by 6. So when I do that, I get this when I divide each of those by 6. Now remember, for no solution, that means like you have to have the system of the system of equations has to look exactly the same, except for like there's one thing that's off, like the number right here and the number right here, where 2/3 is different than -6. So if that's the thing that would be off, and like 12x is the same, 12x is the same there, and we can make the y part the same and the y part the same here, that means to make the y part the same so that there's only that one number off right here, that means that k would have to be -28. Now you might notice you got a negative value here. That is totally fine now. You might not be used to that if you've taken the SAT before, if you're like doing this practice as part of SAT prep, but with the digital SAT, it's a little bit different now where you can get a negative answer for the free response questions. So don't worry if you get a negative answer anymore, because that is allowed now. Now I'm going to show you another thing that you can do as a strategy if you're lost on how to solve a system of equations, or to actually always check a system of equations. If you get an answer for like what your point is that you think works for the system, like for instance, the correct answer to this one would be D. If it's the right answer, it should work when you plug in that x and that y into both equations. So like your x would have to be 3 and your y would have to be 0 for both of these, and both of these have to work when you input that for x and y in order for that to be the solution. So like let's say that you did all the substitution and elimination stuff, or you just like forgot how to do that and wanted to start inputting x and y's for each of these. Like let's start with D just because we know it's the correct answer, so I can show you how it works. You would say, okay, my y is 0. My x is going to be 3, so I'm going to plug in 3 everywhere I see an x. Oh, I meant to put 3 right there because it's 3 minus 3. So then this would be 5 times 0, which is just 0. That works. 0 is equal to 0. And then here, for the second equation, I can't just have it work with one. It has to work with both. So then, like, over here, I would put 0 in for y, and then I'm putting 3 in for x, so then it's 7 times 3 minus 21. 7 times 3 is 21. 21 minus 21 is 0. That works. 0 is equal to 0. Now, let me show you an error that most people would make on this when they're using this strategy to plug in, like plugging in points to solve. So I'm going to show you a way that people might mess up on this. I'm going to just pretend that A instead says -2, 0. So let's say that like the answer choice A was -2, 0. If you wanted to start plugging in points as a strategy to solve this, let me show you how people would mess up with that one. So if this were the point that you're testing, that means that you have to test out x is -2 and y is 0. So I'm going to plug that in over for the first equation. So 0 is equal to, and then -2 is your x. So everywhere I see an x, I'm going to put -2. So -2 plus 2, that is 0. So then you would have 0 and then times -5 right here. That does equal 0. That works. Now, people would probably like mess up there and like pick A because they're like, oh, it works. But you only saw that it worked in the first equation. You didn't check that it worked for both of them. You didn't check that it worked for the second part. It has to work for the system for both of them. So when you go and you put in 0 for y there and you put in -2 into the second equation for x, you're going to get 0 is equal to -14 minus 21. -14 minus 21 does not equal 0, so it does not work for that one. It can't just be a point that works for one of them. It has to work for the system. It has to be a point where the x and y work for both. So that's another strategy you can use besides like the substitution, elimination and stuff, like when it's formatted this way where like they give you potential answers on the test for the digital SAT. And there's a bonus question right here which asks how many solutions are there for this particular system. So you could do the whole, I'm going to set the y's equal to each other and then do the discriminant formula if you want, but I'm going to show you how to do it and see it with Desmos right now. So all I did was I I plugged in exactly what it said for each of the equations right there into Desmos. Now you want to be careful because like you see, oh, they cross at this one point right here, 3, 0, just like we saw. And you might think, oh, there's only one point of intersection. You got to be careful sometimes because if you zoom out, you'll see there's another point of intersection right here, 5, 14. So there are 2 points of intersection, meaning there are 2 solutions for this particular system of equations. So the bonus answer question would be 2. Okay, so let's do number 24 a different way besides graphing how many points of intersection. Again, that's the same thing as how many solutions are there for the system. So I'm going to set the y's equal to each other. So 2x has to equal x plus 15. And I could just solve and I could see, okay, I'm going to subtract x from each side. So then I get x is equal to 15 when I do that. So there's one x value that works for these. So there's only like one solution, one point of intersection for this system of equations. So it should be B1. And you'll see it's not like the x could give you like 2 different values when you plug it in. Like if you plug in 15 for x here, you're going to get 30, and you get the same thing here. Like 15 for x there gives you 30. So like the solution to this would be 15, 30. There's only that one solution, that one point. So then for number 25, what I would do is you'll notice that like one of them doesn't have a y, like the top one doesn't have a y. It doesn't matter. I could just solve for x and I find out that x is equal to 8 for that top one. So I know what x is. It actually just makes my life easier this way. And then I could plug that in. Sorry, I hate how I wrote that 8. And I can just plug that in for x right here and then solve for what y is because it's asking you what's the value of y. So -2 times 8 for the x value minus y has to equal -8. So -2 times 8 is -16 minus y is equal to -8. So now I want to add 16 to each side to get y by itself, or more by itself because it's still not completely by itself, but I'm going to add 16 to each side. It's going to be positive 8 right here. And then if I divide by -1 on each side to get y now completely isolated and by itself, I'm going to get y is equal to -8. So the correct answer should be A. So now it says that we have the system of equations right here. This line right here is g of x. This line over here is f of x. And what is the value of x for the solution to the system? Remember, the solution is like the point where they cross, this x comma y where they cross. The point of intersection is also referred to as the solution, so I just need to know the x value for that point. Now be careful here, and be careful in general on the exam. If you're doing this for digital SAT, this also applies to like ACT. Be careful with the scale that they're using for the x and the y axis. So like here, some people might think each of these cubes is representing 1, but look, it takes 4 cubes to get to 2. So that means each of these is actually a half, because 1/2, and then we get to 1, and then we get to 1.5, and then we get to 2. So each of these cubes represents a half. So if I'm going 3 cubes from 0 to the right, that means I'm going 3 halves. 3 times 1/2, like 3 1/2 to the right. So then 3 times 1/2 is 3 halves, or 1.5. So it would be A right there.